Lending Club, we're the world's largest credit marketplace. We have a great business model. I'm not going to go into that, but it feels really good to be shaking up the financial services industry. We're doing that. It needs shaking up. We're also trying to shake up the financial technology space, and that's what we're going to talk about here. And I'll repeat what I was saying about the blog post that Neo4j put out about a week ago about starting as a hobby. We started this as a hobby, and now it's running our infrastructure of a publicly traded company. It's a good story. So microservices, everyone's doing it, right? We talk to nobody who's not doing microservices. We're really doing it. We moved from 5 production services in 2013 to 2015. Right now, the last count I had was 139 out of Neo4j, of course. I was talking to somebody today who I was interviewing him, and he said, well, tell me about your microservices transition. I said, yeah, we moved from 5 to 139. He's like, I'm glad to hear that because a lot of people get stuck along the way. This is what everybody thinks of when moving to microservices. You know, container, it's nice and neat. I don't know, there's one of them out there. This can be what happens. I don't think it's unusual. Yeah, is it the load balancer? And that'll kind of set the theme for the rest of the presentation, what we're doing, because we're doing a lot of load balancer management. So how do we get from 5 to 139 and do it and deliver agile and financial technology and still have, meet audit and compliance requirements? That's what we're going to talk about here. So, MacGyver. It's not a joke. Looks like I'm just average age. You probably remember MacGyver from the 80s. Ashley doesn't. So what is it? It's all the stuff that Jenkins can't do. So Jenkins is great at a whole bunch of things, and it's fantastic at orchestrating continuous integration, continuous delivery. It's a Swiss Army knife. But it's really bad at certain things. It's not bad at them, it just doesn't try to do them, and it doesn't do them at all. And so what can it do? It can't do real-time API access. There's no database to speak of. So anything interactive and managing state of infrastructure, it just can't really do it. So we put MacGyver together based on Neo4j to fill that deficiency. So with that, I'm going to have Ashley get to the fun stuff here.
Thank you. All right, so integrations. MacGyver is hooked into a lot of different services at Lending Club. Here are a few: GitHub, AWS, Splunk, HipChat. There's more. So there's a lot of things that it's hooked into, and it's constantly talking to all these different services. And so maybe from the load balancer, we'll have service groups. From AWS, we'll have EC2 instances, the firewall rules, or our SAN storage will have arrays and volumes. And so to keep track of all these things, we need a good way to keep track of these things. And while we could use an operational data store, real-time access is costly. And so with these, if you wait to get the data until you actually need it, then it's too late, and you find yourself looking one by one through each of these silos. And you also limit your queries to be very simple, and you're limited to a very small amount of data. So this is not scalable. So instead, as I'm sure you guys have figured out, we use Neo4j. Neo4j has all of the characteristics of a database that we need. Really fast queries, really great join and traversal capabilities, really easy to use, it's flexible, it's very scalable, and really great ad hoc queries through Cypher. So how do we use Neo4j at Lending Club? I have 3 use cases. So first of all, we use it for app check-in and service discovery. So as Rob mentioned, just a couple years ago, we had maybe like 5 microservices, and now we have 139. Actually, I think it's closer to like 150 now. But when we have over 1,000 servers, it's hard to keep track of what's out there and what's going on. And so what we ended up doing is we configured all of our servers to phone home to MacGyver every minute, and we saved all those app instances into Neo4j. So there you'll see the app instances, and so every minute they phone home to MacGyver with information about their app ID or the revision, what environment they're running in, and we save all of that into Neo4j. And so this seems super simple, but just by implementing this, we immediately started to reap a lot of benefits. So we had a real-time database of deployed infrastructure, so every minute the info is kept up to date. When we add new services, they automatically report into MacGyver. We don't have to do any work. They report in, they get saved to Neo4j, and we start monitoring them right away. So super easy to scale. And of course, the ad hoc query with Cypher. So just from this, we were able to ask, show me all the instances of app X in environment Y. And so this was something that was hard to look up before. We might have to go into like vCenter and look up all these different VMs that we have. And now we can just use the simple query, show me all the app instances with this app ID in this environment. And so immediately we were able to get a lot more visibility into what app instances we had out there. We decided to take it a step further, though, with deployment and release automation. So in the past, our deployment and release was highly manual, very tedious. We would use like Excel spreadsheets or even like handwritten notes and like cross all things off of our list. And it was really hard to answer questions like, well, what pool should I deploy to? Is the most recent revision live? Developers would come, they ask this question a lot. Oh, is the most recent revision, is it live yet? Is it live yet? And so all these things would require a manual lookup on DevOps end. So we didn't have a lot of visibility into our services. So our solution to that was to take our app instances that we saved into Neo4j, combine it with some info from our load balancer, and then manipulate that data into Neo4j so that it made sense and we were able to expose information about our live and dark pools, which ultimately enabled us to automate our deployments in a release. So really quickly, at Lending Club, we use blue-green deployments. And so in a blue-green deployment, we have a live pool and a dark pool at any given time. So half the servers are live, half of them are dark within a service group. And so the live pool takes all the traffic, while the dark pool just kind of sits there and is inactive. So during a deployment, we deploy new code to the dark pool, and then QA and release run testing on it. And once they give it a go and they say, okay, the dark pool's good to go, we change the state on it so that this pool here on the right becomes active with a high priority, and we also lower the priority of the pool that's on the left. So what happens now is that all new connections are getting sent to this live pool on the right, and the old connections on the previously live pool, we wait for those to drain out. And once those reach 0, we cut that pool over, right? And so now essentially we have done a pool flip. So now the pool on the right is live and the pool on the left is dark. And so the problem that we had with this previously is that although we had this concept of pools and we used it very strongly or a lot in our deployments, within the load balancer, it was able to associate service groups with the servers, but it did not know what servers were in what pool. And on also, the app instances that we had reporting into MacGyver, they knew their revision and app ID, but they didn't know their state. They didn't know if they were live or dark. And so essentially we were able to use Neo4j to map these servers into pools and automate our deployments. So this is what we just talked about, where app instances, we saved those into Neo4j. So we took the info from the app instances, such like app ID, revisions, environment, and then we combined that. We pulled our load balancer for information on servers such as state, whether it's active, inactive, draining, how many connections does that server have, and we combined that with our app instance nodes, and we were able to create virtual server nodes. And so by collecting virtual servers and aggregating them according to their app ID and their state, we were able to create pools, which is where it gets a little more interesting. So these are application pools in Neo4j, and you'll see the purple dot is a pool. Each pool contains many servers, and each of those servers has a one-to-one mapping to our app instances. And so each pool, because it's pulling info from its virtual servers, it knows whether it's live, dark, or draining. And so each service has a live pool and a dark pool, a pool A and a pool B. And so by mapping the pools into a virtual service, for every service we have a green dot, and there's two pools, pool A, pool B, and then within a pool there's many servers which are mapped to app instances. And so now, because of this, we were able, to gain a lot of visibility into apps that we didn't have before. So these questions that were hard to answer before, we were able to answer them now with Neo4j because of this new data that was exposed. So what pool should I deploy to? Something that we would usually have to bounce into the A10 GUI and look up the servers which were active and which were inactive. It becomes a simple Cypher query, right? So show me the virtual service, this app ID, and this environment, and give me the dark pool. And so right away, it's easy to tell what pool we want to deploy to. Our live pool revisions in sync in different environments. So this is important because, say, our main load balancer fails over to our backup load balancer. We want to make sure that there's not old code running, right? It's the same revision. And so this also becomes a simple Cypher query, which before would have required manual lookup. And then this is an important one. Do multiple revisions exist within a single pool? So it's important we don't want old code and new code running at the same time. And so we just query, show me all the servers within a pool, and if there's more than one revision within a pool, then we know that's a problem. And so if you think about the Knight Capital meltdown in 2012, they lost $440 million because they had old and new code deployed at the same time. And I think if you...
Yeah, that was the end of that. That was the end of that company, I believe, or they got sold off for nothing.
Yeah. This happened in 45 minutes. So if you do the math, it's $163,000 that they were losing per second, which is crazy. So they should have used Neo4j.
Yeah, it's an easy mistake to make. So we get paged. If it were to happen, we get paged.
Yeah, and so a lot of these queries we run throughout the day periodically, and they'll page us. They'll tell us if something is wrong. So a high-level overview of what we just covered. The app instances report into MacGyver. They get saved to Neo4j. We take some info from the load balancer and combine that with our app instance info. And from that, we're able to create virtual servers. From there, we group those servers into pools, and then we connect those pools into virtual services. And really, the reason that we were able to do all this was because of these pools that we were able to create with Neo4j. Because Neo4j is so good at mapping relationships, it was really perfect for this use case. And not only can we monitor all our virtual services now, but at the same time, because Neo4j always is able to tell MacGyver, oh, this pool is dark, this pool is live, we can also send commands to the load balancer. And this is how we're able to automate our deployment. So at any time, if you say, I want to deploy this revision of this app into this environment, you can query MacGyver, and MacGyver will say, this pool is dark, we're going to deploy this pool. So you can deploy in MacGyver, and then you can start off a drain in MacGyver, and then MacGyver also, because it knows the number of connections to all of its servers, it can automatically just cut the pool over. Okay, and so last use case, infrastructure mapping. So similar to the problem where with our services, we didn't have a lot of visibility into what pools were live, what pools were dark, what servers were in a virtual service, or even what app instances were out there. This problem kind of extended to our entire infrastructure. And so once we kind of got started with Neo4j and we started playing around with the virtual servers and services, we were like, hey, we could map out our entire infrastructure with this. So here you'll see this is what we just talked about. Every virtual service contains two pools, which contains a number of virtual servers, which maps to an app instance. And so exposing this data allowed us to ask, this is another check that we run periodically, are any servers in a live pool degraded? Right? We don't want an unhealthy server in our live pool. So basically, the state and the priority is saying that's what determines if a server is live and active, if it's healthy. And so if those conditions aren't met, then it returns that server and we get a ping about it. And so from there, we decided to add stuff from vCenter in. So all the app instances were like, well, these map to compute instances, which are hosted by compute hosts. And so we added a bunch of more nodes from vCenter into Neo4j. And so we were able to extend this, and so now we can ask the question, well, do we have a single point of failure among our servers, or among our services, sorry. And so if at any given time within a pool, if all those servers are hosted on one host in vCenter, if that host is to go down, then we definitely have a problem. And so because we were mapping this in Neo4j, we were able to expose this data in a way that we weren't able to before. So this query is kind of wordy, but it shows the traversal, I think, pretty well from pool to virtual server to app instance to compute instance to compute host.
Can I comment on this? So I love this because vCenter has a habit with vMotion of deciding to go move things around. But what has it done? And if you don't have affinity set up in vCenter, it's really easy to set yourself up for these single points of failure. So we were constantly scanning the infrastructure, and then and again, we get paged when something happens that we don't want to. If we didn't do that, what would I be doing? I'd be asking staff, is it okay? Is it okay? Is it okay? Can you look again? Can you look again? But we want the infrastructure to tell us. We want to be reacting to problems, not having to go constantly look.
Yeah. And this problem is also really hard. If you're just looking in vCenter at a host, it's hard to know, is there a single point of failure here? And so really we're just taking data but making sense of it within Neo4j and exposing it in a way where it became useful to us. So we continue. So the nibbles are our storage arrays and our storage volumes. So we added that into our infrastructure mapping. And so now you can see, if we want, we can traverse this graph all the way from a virtual service to, for example, a storage array or a storage volume. So now if we want to ask the question, if this storage volume goes down, what services are going to be impacted? Again, it's a really simple query, and it runs really quickly, and it tells us things that we never had visibility into before. And so I think the cool thing here is, as Rob was saying, it kind of started out where we were using Neo4j, kind of just playing with it as a hobby. We're like, oh, it'll be cool if we put our app instances into Neo4j. And then from there, we're like, oh, well, app instances, we can map those pretty easily into virtual services. And then because that information was there, we were able to automate our deployments. And from there, we just kind of kept building and building on our data set that we already had, which is kind of one of the things that I think is cool about Neo4j, is that you can develop incrementally. I'm sure, like when we first started, we didn't know we were going to end up with this. And we're still progressing. Like we're adding firewall rules. We could add databases. As we move into Amazon, we can get EC2 instances, security groups. And so it's pretty cool. It's easy to build on your data set and make it more complex. So other use cases, I kind of talked about that already. So continuing to build out our infrastructure mapping is one thing. Also, our information security group has taken some interest in MacGyver recently for like service onboarding. We can have a service registration in MacGyver. So when we get new services, we can register with MacGyver. Well, is this service allowed to talk to this service? And we could have a graph of relationships of services that depend on one another or talk to each other. Also, we use it for rezoning. Is this server in the correct zone, security zone? Are there other ones?
Yeah, I'll talk a little bit about this. We want to keep this agile culture going in the company, and we don't want to have meetings and change review boards and all that kind of stuff that nobody really likes. So the information security use cases, I think it's a great one for the continuation of DevOps, and how are we going to move from 5 services to 139 to 400, and at the same time that the company's getting bigger. Here's what we can't have meetings and change review boards to get there. So our information security group, which is just absolutely fantastic, they're on board with this because they want to hook into it, and they want to react to, a developer has created a new service. I need to chain my workflow to that. Maybe I need to start running app scans on it. Maybe I need to have a conversation with that Scrum team to understand what it is. Maybe I'm going to ask them to provide attributes about it so that we know how to classify it, so that we know how to do data classification. So the opportunities here for continuing this DevOps mindset and using Neo4j, it's limitless. Yeah, we're really excited, particularly with we're moving into AWS, and the API control plane has such a rich variety of information, but it's kind of hard to query. You're making a lot of API calls, and as we've started doing that automation, yeah, it's slow. Something that will take 15 seconds to make 20 different queries out to AWS. We want it to come back like this so that we can have fast, responsive APIs that allow us to deliver the services that we want.
Yeah. So in the end, everything is awesome. Microservices, we have a lot of individual, Lego blocks, and we might switch them out, we might move them around. And as Rob was saying, sometimes it can get messy, but using Neo4j to manage it has made it a lot easier. And we will continue to use Neo4j. And that's it. So for more info, that first link is our open source MacGyver, so nothing Lending Club specific. The second link is a pretty cool Neo4j REST client that Rob wrote. It's implemented with Java RX observables. That's what we use for MacGyver. And
I'll talk about that for a second. Yeah, check it out. It's if you're interested, if you're writing on the Java side. It was before we had Java 8 available. Maybe if I did it today, I might use streams. But yeah, we took the Java reactive extensions and grafted them onto a simple REST driver, which is delightful to use, totally fluent. So you can write a query or an update in a single line of code. There's some great examples there. So it's not necessarily the most memory efficient thing in the world, but is fantastically productive to get stuff out of Neo4j.
Yep, that's it. So I think we stayed in time. Do we have time?
Any questions? Yes.
By the way, it's very cool. I like it.
Yeah, we love it. It's fun.
One question that I have is do you guys have like it does a pretty cool job at the dev side and the automation side deployment, but does it have from the ops side, does it have like kind of a dashboard which gives us the health of the environment, like kind of availability, performance, capacity, and then everybody can look at it and then,
So yes and no. We're hooked into so many different, and we have so much monitoring, we don't know what to do with this monitor, right? We've got Graphite monitoring, we have New Relic, we have, what do we have? We use a ton of Splunk, all kinds of different things. So what are we trying? Yeah, these are what you're getting at is, yes, it's absolutely the holy grail is to be able to be pulling all that information and aggregating it together. So it does have a UI to it, and yes, the integration page that showed a bunch of those things. We're constantly going out to all of those systems, ingesting that data, processing it, and then taking action. I don't know if I'm answering the question, but I think the answer is yes. But yeah, all that data it's over in New Relic's data center. It's in Splunk. So we're aggregating it all together and then taking some action.
Awesome. Yeah. The other question that I have is, it works with the AWS. I'm pretty sure it will work with the Google Cloud or Azure or anything, right?
It uses, we use kind of a little plug-in model. It's really simple. It's not even as complicated as Jenkins's plug-in model. And our approach is just to give the core platform gives you a batch scheduler. It's Spring Boot based and a UI, so we can easily add in new UI components. And then it gives stubs into all these integrations end up being REST-based integrations. So we just have stubs that are in there. They're in there securely. We have password encryption, and then from there we have GitHub or Git grafted on. And so we've got this great model that we use elsewhere in the company, which is we have a script library that sits off in GitHub, and MacGyver's going out and pulling the Git library. So if you want to do something simple that's like 2 APIs together and you want to write 10 lines of Groovy code to go mash them together and then go do something and set that up to be scheduled and then take action. So it's like run some of the queries that Ashley was talking about and then send an email and then send a page. So in some sense, we've kind of built a enterprise version of if this, then that. And so we've been able to do a whole bunch of things like we built a chatbot system a couple of weeks ago where we're hooking into HipChat, goes through AWS, ends up back into MacGyver so that we can, one of the problems that I had was we'd be in the middle of an incident. They don't happen that often, but they happen. And we're supposed to be documenting that incident as we go. And everyone's living and breathing in HipChat. It's fantastic. But nobody's opening the Jira ticket, right? And it's just one step too far to get out of HipChat, go into Jira, open it up so that the incident can be started. So what would end up happening is, the incident would get resolved, 2 hours or whatever it takes to get it to resolve. And then the next day, it's like, oh man, now I've got to go open an incident. Well, now we can just do, slash incident, boom, 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 the link shows up, and you can just start pasting data in there. So yeah, if this, then that, we can thread together and react to all kinds of different stuff.
Okay. So
yes.
Yeah, this is awesome. Couple of questions. You showed blue-green deployment. So does it mean that half of your infrastructure is idle while you're developing? And
it does.
Okay.
It does.
So
that's
that's
part of the reason we're moving to AWS, so that we're not warming the environment with our idling infrastructure.
Okay, but right now you're paying, or your management is paying for that infrastructure just to sit idle.
Yeah, and we love it. I mean, we love that management's willing to pay for that, and it's fantastic. And we run a whole separate data center that's sitting there doing nothing, which is fantastic. I mean, not a whole data center, but I'm going to sing the praises of our company. But what does that allow us to do? It allows us to fail over and run the entire company off of a backup data center with almost no effort. Last year when we did it, I nearly fell asleep during the failover procedure. We're legally obligated to do that for audit and compliance purposes. I nearly fell asleep during it because there was almost nothing to do. So it's fantastic to have the support at the company to be able to run infrastructure the way we want to run infrastructure.
Correct.
And hey, we're good at it, right? We went 5 to 139, and we don't have the ship falling over.
So one more question. I see that this can be extended, or maybe you have already done it, is predicting the problems before it happens, because that's one of the questions that always comes up. How come you didn't realize that you are reaching 80% disk space, or your database space is filling up quickly? And using this, do you guys use it to send alerts proactively that, hey, this is overloaded, or response time has gone like more than double, things like that?
Yeah, absolutely. And if I'm going to kind of re-theme what we're doing, and I think I probably will over time, I really like this idea of reactive infrastructure. So the reactive movement in software, apply that to operations so that systems react to their own behaviors. So it's not coming for the human being, and we're not worrying about a human being looking at a screen, and that we've got this all programmed in. So half of my job description, running operations, is coming up with these ideas to get exactly the kinds of things that get those implemented and operationalized, because that's the only way that our small team of our team is six or seven, can support 300 engineers and several million lines of code being shipped constantly in continuous deployment. So it's the only way. It was done out of necessity. It's the only way that we can keep things running. Anybody else?
Last one. Just a small question. First of all, awesome presentation. And will the slides be available somewhere?
We will make them available, absolutely. Send a tweet to one of us, and we'll get it out.
All right, thanks.
Okay?
Yeah, that's it.
Thank you.